So first of all, thank you for having me here, Josh. When I met Josh, I'm like, hey, I can trust this guy. He's bald, I'm bald, so we're good. We're good, Josh. In terms of the question, uh, the whole concept of blockchain has really kind of the last 13, 14 years has kind of come into the mainstream. But in terms of just some brief history about how it came to be and then what it is, uh, really, blockchain is a shared database. It's known just as a distributed ledger technology. So imagine that in your organization, you have a database, actually a very simple database that is shared across. Now, what's so interesting about this database, this ledger, is that it is what we call fault tolerant, highly resilient, and it is distributed. And this is really the basis of this technology that has a potential to change a lot of things. But it is it's something that has been around and has proven itself with these properties of being very resilient. Bitcoin today does about 190 billion, and it has not been hacked.
So thanks for that. So when you say distributed, would you say that blockchain is kind of analogous to what the internet is, where it doesn't reside in one place, but it resides in anybody that uses it becomes a part of it in a way?
No, that's a very good analogy. I mean, one thing that we have to differentiate when we think of the internet, we think of very interconnected nodes, and we think of information kind of crossing those interconnected nodes. Now, the thing about blockchain that's so interesting is that we don't call it an information technology. What we do is we call it an institutional technology because it's the first time in history where we could substitute organizations for a trusted system.
Okay.
So it's easier to think about this in that context, even though there's information flowing, but it really is a way for us to provide technological institutions that are not manned by humans. And of course, the distributed aspect, the internet is distributed, is fault tolerant, but as we all know, it can be hacked. Internet technologies can be hacked. It is much more resilient based on all the security technologies, the cryptographic technologies that are there.
What was blockchain's main problem that they're trying to solve? What is blockchain trying to solve?
It's a very good question. Why did this technology emerge, and why is there such a heavy interest in it? If you think about what the internet was supposed to be when it started, it was really supposed to be a peer-to-peer system, web servers, clients, and it was supposed to be decentralized. That was the vision of the internet back in the early 1990s. But what resulted in that is really centralization of data by a few companies. In fact, the estimate right now is that over 90% of all information is controlled by 10 companies around the world. And this is the path that, as technologists, which developed the whole concept of the internet, this is not what they were striving for. What they were striving for was an internet that is peer-to-peer, that is resilient, meaning that right now when you go on the internet, you find a lot of broken links. And really, that's not supposed to happen. So that's one pain point, is the power concentration. There's another pain point, and that is resources. If you think about the companies that control all this, a lot of our data, what they're doing is they're putting a lot of their resources and effort and monetary funds into competing with each other instead of providing better services, better business services to our end users. So there's a lot of resources going, and redundant resources. I mean, if you think about Twitter, Facebook, what are they doing? If you look at a basic company, what is a basic company? A basic company has data, it has technical processes on top of that data, and has business processes on top of that data. And a lot of the effort and concentration is going into doing the same thing over and over again in a redundant way by these different companies. They're all doing basically the same thing. They're optimizing their technical services when they should be providing services that are probably much more maybe to what the consumers want, or at least make progress in that area. So I mentioned that there's this model today where you have data, you have technical services, and then you have business services that sit on top. Those are the layers. What the blockchain is attempting to do is that we are attempting to kind of break that model in such a way where we do datafication at the data layer and provide that data in an open source and provide it to everyone who wants to use it. This idea of datafication, and this is where Internet of Things, IoT devices come into play. There are a lot of IoT devices, I think I was speaking to someone here, that are going to come into the blockchain, and they're providing the data, the datafication. A lot of our cars are going to be datafied into the blockchain, right? And the whole idea is that instead of one company owning that data, now you don't have a company, you don't have humans. What you have here is a organization, a technological organization that is providing this data to anybody that wants to use it. Now, so blockchain is going to change the idea of datafication instead of being control. And then once you have datafication, then you're going to have what are called these technical services that are going to kind of be utilized as a result of this datafication. And now you're going to start to see companies doing business a little differently than they're doing it now. Because now we take things for granted that this is the way it is. Companies like Google, Facebook, everybody's doing the way it is right now. But imagine if your profile is not subject to one company, your normal profile. It is actually something that is distributed, that is that can be found by anyone, and they can provide different services on top of that, and it's peer-to-peer. That's a more important thing. It's a peer-to-peer service. There's no reason why an email, if I send you, Josh, an email, there's no reason why I should go through Google. It can go directly to you, right? We can be interconnected as a peer-to-peer to you. And if you want to send me money, Josh, which I know you want to send me money, right? You don't want to have a third party like a bank, right? You want to be able to route that money without a human being involved in a very secure, highly tolerant way. So these are some of the pain points that this particular technology is going to offer, is this replacement of human organizations with a technological organization.
How does that affect privacy, for example?
In terms of security, if you look at how much effort is spent on securing your data in our organization, it's a lot. And in most of the cases, a lot of companies get hacked. At the end of the day, a database is raw data. It's got clear text because you have many developers working on it. Any disgruntled employee who's an admin, DB admin, or has access to the database can literally take a snapshot and take it home. Right? We all know that, people that work in this field. With blockchain technology, it is not the case. It is inherently, from the beginning, all data, it is highly secured using some of the most proven cryptographic security technologies that are in place today. So you have what is called a private key, and your private key essentially will dictate that encryption in such a way where the data that is available to everybody is encrypted and cannot actually be read or decrypted without your private key. And it is up to the user at that point to keep their private key private, but it is up to this point impossible, unless you have a quantum computer. For those of you that are on quantum computing, I love quantum computing. It is nearly impossible to decrypt that information once it's on the distributed ledger or blockchain.
All right. So even though the data is out there, it's encrypted, it's protected, it's still private, but it's no longer just sitting in one silo. It can really not be replicated because I can replicate a silo. I can replicate many places in one.
There's data that is in a node, in a blockchain node like Bitcoin, that is not actually parsed out into different pieces and put into different chains. So in this case, so you take something like a blockchain like Bitcoin or Ethereum, when you create your own node, let's call it the Bitcoin node, you're actually getting a whole copy of everyone's data. And so you have that, but in one place, you do have that that data, but of course you can't encrypt it because you don't have the private keys. However, there are blockchain technologies out there. I think one of them is called Storj. Storj? Yeah, Storj is a blockchain cloud storage technology. And that's exactly what you described. What they do is they use blockchain and they take a file and they'll distribute it throughout all these different nodes. So no one node holds the whole file. It's different portions of the file. And you're right. Can someone go out there and grab all the different pieces? But they cannot decrypt it. So different technologies that are around in terms of how they store data. Some of them have the whole data. Some of them have dispersed data.
How does blockchain help the average consumer as we go forward?
In terms of how it's going to help our society, we have merchants and we have consumers that are transacting all day long. An example that you tell me, someone's got a brewery. Well, think about what that brewery is doing. It's buying things from a supplier, and it's wanting to know perhaps where this stuff is coming from. If it's organic or not, they want to have some level of traceability, but they also want to transact faster. So imagine that they're buying wheat from the supplier, and so look at that transaction. They need to wire the money in. They need the supply chain to actually authorize the delivery. The delivery comes. That whole process, in terms of what blockchain can do, it can actually make it more efficient. Imagine now you have the brewery owner who's buying the stuff. They have their wallets and they have their private keys. And there's a smart contract, which we can talk about in a bit, which actually are coded rules for making business transactions. If the buyer and the seller is willing to commence in this transaction, at that point, that transaction can all be done within a matter of a few seconds because there would be a connection to the funds and they would authorize it and it would be done. It'd be a lot more efficient process. And that actually happens a lot with other things. I mean, brewery may not be the best example, but other things like buying a car. You look at buying a car, you're there for 5 hours. I mean, you look at Carvana has made it a little easier, right? But they're actually going bankrupt, I think, of it. But any transaction that takes a long time, if you look at all the parties involved, what are they really doing? They're actually following some level of rules that they are dictated by. The bank has the rules, the buyer has rules, the seller has rules. Well, the fact is, and it's happening today, those rules can be coded into a smart contract. Where I see a car online, there's a buyer and a seller, okay, and there is a bridge, there's a Web3 app that is blockchain, and that has access to my funds, my Bitcoin and my Ethereum funds, and I want that car. Transact, boom, 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 on the blockchain, and your title for the car is now an NFT, which is a blockchain. It doesn't have to be a physical thing. You'll get an address in your wallet. You will receive a NFT that represents your. I'm not saying this has happened today, but this is what can happen. What should happen really is represent anything that's unique into an NFT, and you're done. You took that process from being hours to a matter of seconds. Now there are obviously other processes like what we do in real estate. Those actually take longer, and we use the blockchain to make to make really what would be a 1 month process into a 1 hour process using the blockchain to represent your ownership of a property.
Where are we going with blockchain? Where do you see blockchain in the next 3 to 5 years?
So first of all, going back to the idea of datafication, what we're seeing in the short term is a lot of data is going to be put on the blockchain. That's step number one. So that's happening right now. We should see more of it. It's the idea of datafication process. And what's going to happen next is that based on the regulations that we're in, there's going to be a lot of businesses that are going to want to be more efficient in the way they transact. And there's going to be what I call these smart contracts. And for those of you that don't know what smart contracts are, let me just kind of briefly say what they are. In a blockchain like Bitcoin, which does not have smart contracts, it is really designed to do these crypto transactions very efficiently. However, something like Ethereum, which is something that came after Bitcoin, that blockchain allowed coded modules, what are called smart contracts, to sit on top of the blockchain, meaning that those could be coded with business rules in such a way where multiple parties can come in, and once they authorize transaction, it can actually do coded business rules, right? In this case, buying a car. What would happen is the buyer, the seller, the bank can all come together and say, oh yeah, we agree, we're going to sell this car. What's going to happen, this coded contract will then execute the transaction, deliver the funds, and then bring you the NFT, the deed of the car, to you in your crypto wallet. So those are what smart contracts are. There's going to be more of those development on top. But what's so really fascinating about what's going to happen next is we don't know what's going to happen next, because we're in what we call Internet 2.0. A lot of people hear about Internet 3.0, Web 3.0. And that is actually up for grabs, because once you start to datafy on the blockchain, then you're going to be able to build a lot of these services, peer-to-peer services, that even today we can't imagine what they will be. You're going to break down barriers. For example, imagine you sending money to India. Right now, that is a very costly process. In fact, there's a whole underground system for that, right? It takes days and it costs a hell of a lot of money. But that process can now be legitimized. It can actually be processed on something like this technology.
Thank you so much for coming here. Thanks everyone for giving us some time.